So I'm going to go over the periodic table. Periodic table starts with hydrogen, then it's got helium, and these two are at the top of the periodic table. Then we have these are the groups of the periodic table. So this will be in the first column. This will be in the 8th column. Now the 8th column ones are called ideal gases. They're kind of just called ideal because they don't react. And that's the ideal state for something, which means the best state that the element will try to get to. It's ideal because it has filled all of its kind of groups. And everything was really to do with these groups, or electron shells, electron groups. So the electron shells go like this, 288. So the first shell, which is in the inner shell, can only take 2 electrons. The second shell, which is the second shell outside of the inner one, can take 8 electrons. And the third shell can also take 8. So whenever something reaches one of these perfect things, like for example helium, it has a full first electron shell, helium. So it's ideal because that's what all types of elements are trying to get to. Other elements don't have that, and they have to go a different route to get to there. For example, we have chlorine. So chlorine is 2, 8, and then a 7. So it's missing 1. It needs plus 1 to get to 2, 8, 8. And if you add 1 electron, which is what all of these structures are about, they're the number of electrons, then you get 288. But it's not called chlorine anymore, because chlorine is 17, meaning it has 17 electrons. See, 2 plus 8 plus 7, 17. And then we add the 1, it'll become 18. So it'll actually be Cl minus, because it has 18 electrons. So here, the 17 is like the number of protons plus or the number of electrons. And it's or because the number of protons is 17 and the number of electrons is 17. And they're equal so that there's no charge. Okay. So that is actually why things form compounds and why they form molecules, because they want to fill up each electron shell. So if we look at this again, we can see, let's look at sodium chloride. Sodium chloride is Na plus Cl minus, and they join together. It's ionic. The reason this happens in the first place is because sodium has 2, 8, and then 1. Okay. So obviously it could add on 7 and then it would become 288. But it can't really get 7 electrons very easily. So usually when it's closer to 0 there, it'll cut down and it will become 280. So we can just write that it's 28. If you get rid of 1 electron, then you have positive charge, so it's Na plus. Okay, so that's why sodium forms Na plus and not Na7 minus. If you added 7 electrons on and became 288, you actually don't ever get that. You always get this. Okay, so what about chlorine? Chlorine goes from Cl, which is 287, to become 288. And that's why the electron goes from the sodium and it goes to the chloride ion. So there's actually an electron there being transferred. Okay, once they're charged, they attract opposite charges and they're exactly opposite, so you get NaCl. And together, NaCl is totally different to sodium or chloride. So you end up with something like a kind of, it's a salt, and it's made from a metal. Anything that makes a positive ion is a metal, so anything in the groups that form positive ions is a metal, so that means sodium is a metal, and anything in the groups that form negative ions is a gas. So chloride is a gas, or chlorine is a gas, and then it's also a non-metal. Okay, so a formula is used to kind of show what's in each thing. So we can have carbon plus O2 equals CO2. That just means there are two oxygens and 1 times carbon, and the number always comes after the atom it's talking about. So here it's 2 oxygens again, and you'll see that each side is equal. So there is 1 carbon on the left and 1 on the right, and there's 2 oxygens and there's 2 oxygens. So this helps you when you're trying to balance out equations. So here we go. You can have a word equation, which is really easy, you just write it out using words, or you can have a symbol equation. Okay, so if we have 2mg plus O2, first we can go see on the periodic table which group is magnesium in. It's in the second group. And if you remember, that means it has 2 electrons in this outside shell. So every sort of element will try to get rid of the electrons in its outside shell, or make it up to the number 8 or 2, depending on which shell it is. So for magnesium, it needs to go down, doesn't it? Because it has 2 in its outside shell, and it's easier to get rid of 2 than to add 6 and get 8. So we'll go from 2, 8, 2 to 2, 8, 0. That just means that there are 2 electrons in the beginning and 8 on the outside. And it gets rid of the outer shell that used to be there when it becomes the Mg2+. It's Mg2+ because it's got rid of 2 at the outside. 2. So you come 280. Okay, so we have 2Mg plus O2, and then we have, to keep it all very balanced, there has to be the same number on that side as on this side. We put the 2 in front because we're not saying there are 2 of oxygen or 2 of magnesium, but we're saying there's 2 of the whole thing joined together. So here there are 2 magnesiums, and here there are 2 oxygens attached to each other. The 2 comes at the end because it's showing you that that's a molecule, and the 2 go in the beginning because it's showing you that these are atoms, just 2 groups of atoms. Okay, so the 2 here is coming here because it's telling you it's 2 compounds up here. While here, this isn't a compound because it has only 1 type of element. Okay, so that's the first formula that's been balanced. Now, an example of another one, maybe a little trickier, is sulfuric acid and sodium hydroxide. So that reacts because you have an acid on one side and you have an alkali on the other side. So if you react an acid and an alkali, you get a salt and you get water sometimes. So that's a good one to remember. So acid plus alkali equals salt plus water, and this is going to be the formula for it. H2SO4 plus NaOH. So OH means hydroxide, and that's going to be the left side, this is going to be the right side. So you get Na2. So it's NO2 there because up there you have to have had a balanced kind of equation. So what do we do to balance this out? We have to add 2 there, because otherwise there'd be 2 sodiums here and only 1 there. So we have Na2SO4. So SO4 does balance with that. Then the problem is we have 2 here, which means there's 2 sodiums and 2 hydroxides. So we can't just write H2O anymore, because then you'd have 2 H's there, and you'd have 2 H's there and 2 oxygens there. Alright, so we need to balance this out. So if we count how many hydrogens there are up here, there are 2 hydrogens here because of the 2 outside on the right of the hydrogen in hydrogen sulfuric acid, and here we have the hydrogen at the end of the sodium hydroxide, and there are two of them because of the two there, saying there's two of these compounds. So altogether we have 4 hydrogens, and here we only have one. We have 2, so one group of 2 hydrogens. So obviously, since that's the only place there are hydrogens, we have to do 2 times this, because we can't change this formula or it won't be water anymore. So there we've balanced out the number of hydrogens. There are 4 hydrogens, but we've also made it so there are 2 oxygens here, okay, because it's 2 times the whole thing. So it's 2 times oxygen there, and we have 6 oxygens altogether because there are 4 here. So that's 4 oxygens there, 2 oxygens there, so we've got 6 oxygens. So let's check up here. This one has 2 oxygens, this one has 4 oxygens, so that's 6 oxygens. So let's check the sodiums now. 2 sodiums, 2 sodiums, SO4, 1 SO4. So that's balanced out, and you can write it out once it's balanced as H2SO4 plus 2 NaOH goes to Na2SO4 plus 2H2O. So that all balances out. So you really just have to do it one step at a time without changing the formulas of each thing. So for example, I couldn't have just done H4O because that wouldn't be water anymore. I have to change it to 2H2O.